turning safety critical into cyber secure and reliable development with a focus on the compiler and libraries. So this will be a fascinating topic, something I don't think you've probably ever seen before. So at this time, we'd like to go ahead, dive in, and begin this webinar. So let's take a look. First, a quick introduction. My name is Vance Hilderman, and with me from AFuzion is Aaron David. He manages the cybersecurity of AFuzion. And AFuzion is a 45-engineer company that focuses on process optimization for safety critical. Hundreds of companies, thousands of engineers use our templates checklist. We provide mentoring and training in 30 countries throughout the world. And we have trained over 25,000 engineers. We also do these days, of course, remote and virtual training. And Solid Sands, our partner in this webinar, is the world leader in C and C++ compiler and library testing, really critical. They're based in Amsterdam, the Netherlands, and have over 10 staff members. They've been working for many, many years, and their SuperTest product has a 35-year track record of really improving our safety critical realm. SuperTest is really the industry standard for functional safety and mission critical markets. So thank you very much for coming, and we'll introduce Marcel in just a few minutes. Let's begin. You know these webinars. We like to test your morning, evening, afternoon coffee content. Let's have a little 7-question quiz, true or false. So this is better odds than Las Vegas, right? Let's see how you do on these questions. We'll answer these questions in 40 minutes, and then we'll have time for Q&A. So ponder your questions and submit those questions through the control panel on your right. True or false? Software testing is the best method to improve quality. Seems likely. Number 2, buying a good compiler means you trust it. Kind of like buying a car, right? Number 3, true or false? Cybersecurity should focus primarily upon penetration testing assessment. See if you are secure. Number 4, compiler libraries are typically well tested and generally have sufficient security and reliability. Number 5, dynamic software testing is similarly efficient and as effective as static testing. Number 6, compiler qualification is not necessary if you do on-target testing. And number 7, open source compilers cannot be qualified for safety critical applications. What do you think? 7 easy questions. Let's dive. Now first, what is safety critical really? Most of you are working with software, hardware, probably safety critical. Well, remember, safety critical is a system whose failure or malfunction could result in one or more of death or serious injury to people, loss or severe damage to equipment or property, or environmental harm. Today, even the ubiquitous cell phone is safety critical. Well, let's consider software reliability. What is software reliability? Well, it's the probability of failure-free software that's going to operate for a specified period of time in a specified environment. Now, for safety-critical systems, let's consider. For safety-critical systems that contain software, software reliability is an important factor affecting system reliability, okay? So we need to consider, in parallel, increasingly the realm of cybersecurity. So what is cybersecurity? It's the protection of computer systems from intentional malfeasance. How's that for English? Okay, malfeasance. Intent to disrupt or misdirect those systems' intended operations. Cybersecurity isn't about bugs and defects. That's why we have automotive, medical, nuclear, train, airplane standards and guidelines, right? Cybersecurity is you and the robots. Now, let's consider the ecosystem of safety-critical engineering. All safety-critical realms, they have upfront planning, okay? You plan for your development, your V&V, configuration management, QA, certification perhaps. Then they have a development process. In the old days, really old, it was the waterfall, and no one really used that. Maybe it's the V model, spiral, perhaps agile, safe agile. But the software development process follows the planning. And then finally, you have in the background, continuous process. Did you follow the plans of verification, validation, CM, QA? Remember V&V. Verification, does implementation meet the requirements? Validation, do you have the right requirements? So that's the realm, typically, with safety critical software. Now, let's consider the types of testing. Dynamic software testing is good. You all need it. Dynamic software testing is the executing of software to determine if the expected outputs are achieved for a given set of inputs. It's necessary. All safety critical realms want us to perform dynamic actual testing, preferably on the target. However, it's very expensive to do it well. You're never really done, but hopefully it's automated and you have full requirements and code coverage. Now, this is one of the quiz questions. Testing. The best phase in which to remove software defects except for all the others. So you know what that implies. It's not the best. Hope you got that one right on the quiz. Now, what's wrong really in safety critical or Microsoft, Apple, Samsung with dynamic software testing? There's nothing. There's nothing wrong with it. It's truly a pillar, a foundation of safety critical software. You need to test and test it well. However, remember, my professor at USC, the famous Dr. Barry Beam, you've probably heard of him or used his work. He's the USC professor who invented COCOMO, software engineering economics, right? Dr. Beam says finding bugs via testing is 7 times, 700% more expensive than preventing the bugs. So the focus instead first should be on defect prevention. And that's where we're at today with cyber, okay, vulnerability, with Solid Sands, with compilers and libraries. Let's take a look. Now, defect and malware prevention, we really need to emphasize prevention and detection over the bug fixing, okay? So we want to use a formal software engineering framework, processes, reviews, okay? Now, our company, AFuzion, we provide those frameworks. Hundreds of companies use them, 7,000 engineers worldwide. There's 2 key activities associated with those. First is the cybersecurity aspect during development, during operation, and update. It's a dynamic realm. But very important and often overlooked is the compiler, the very essence. Let's be honest. What's the most important tool in software development? The compiler. Compilers use libraries. So we need to consider the validation and library aspects, okay? So right now, I would like to turn it over to Mr. Aaron David of AFuzion InfoSec. And Aaron will tell us about cybersecurity for safety critical, giving us an example with DO326. Aaron, please take it.
Thank you very much, Vance. Now, a quick look into the new emerging DO326 ED202 family of standards. In the old times, where all we were concerned about is safety, we had DO178 in Europe, known as ED12. That dealt with aviation safety critical guidelines for the development of software. And it took care of robustness against natural hazards. Whereas starting off this year, a little bit earlier, we're looking at the new essentials for security. That's the DO326A and ED202A, plus the DO356A and ED203A. The DOs are in the United States, ED are in Europe, but they're identical. These documents deal with aviation cybersecurity guidance, and they are meant to provide resilience against intentional threats, man-made hazards, not natural hazards. For both safety and security, we are mandated to have during the development process risk assessment, mitigation of the risks that are deemed unacceptable, and assurance that we have mitigated that properly. Now, security risk mitigation is required for the additional security measures we put in order to secure our system against intentional, unauthorized digital threats. This mitigation is also required for to enhance the development by secure development assurance, secure development procedures, and secure assurance. You have to have security in place with measures. You have to have secure development and assurance for the measures and for the rest of the lot. We'll see that immediately. Security measures, type of security measures that we recognize are procedural measures. You don't necessarily need to rely solely on software or hardware or even any technical security measures. Procedures are part of the mitigation process. But then we have, of course, hardware, software combined, and other types of measures. Now, the security development and assurance is required for the security measures themselves. The fact that we call them security measures does not make them automatically secure. We have to take care that the security measures themselves are secure. And for what we now call assets, like your flight control system, your engine control system, all your essential systems in the aircraft, the airborne systems, are collectively called assets. Safety critical items, interfaces, also infrastructure that supports these assets are also assets. So the bottom line, you need to have secure software development and assurance for all software that is deemed safety critical on board, or software that can make other safety critical software unsafe. Okay. For this secure software development and assurance process, we need to look at the requirements, the design, the implementation, the verification, the plain standards that you would get to know, and you may rush to DO 326, 356, and ED 202, 203, but they would not tell you what solutions to choose. They would just mandate the processes you would use to choose these solutions and to implement them. One example I would like to just throw at your direction from the implementation phase of software development. When you go from safe development to secure development, you need to add some extra layers, some extra procedures to the development process. And the classic example is if we take MISRA C 2012, which I guess all, or at least most of you do know, and some of you even use, there is an Amendment 1 to MISRA C 2012, and it adds a security layer for the coding procedures. Now, one example I'm just pulling out is eliminating control access to connections. Doing that is mandated by DO 356 and ED 203A, and the immediate solution would be to apply it by software, of course, or at least one of the solutions, one of the most popular solutions. And then your solution can be to comply, for your solution for security assurance for the process would be to comply with the MISRA C 2012 Amendment 1, to check all the boxes, in which one of the boxes is Directive 4.14, the validity of values received from external sources shall be checked. If you do that, you have a great head start with complying with eliminating and or controlling access to all collections as mandated by DO 356 ED 203A. The complete set of mandates for development only, there's a huge set of standards, but the core of the standards for the development phase is DO 326A or ED 202A plus DO 356A with ED 203A. But if you want to implement them in practice, it's not sufficient to just go ahead and read the standards. They are not easy reading material to say the least. So you would need to have gap analysis, checklists, ready-made checklists, tailor-made checklists, and even training on these standards, because they're not very easy to cope with, such as we provide at AFuzion already for quite some time. Now I will pass you to the good hands of Mr. Marcel Beemstel, right from sunny Tel Aviv to sunny Amsterdam. But before I do that, a quick homage to our great partners from the Netherlands, saying how much we appreciate them, from Dutch pop group from half a century ago, the T-set, called Ma Belle Amie. Alsjeblieft, Marcel.
Ma belle amie, you were a child of the sun and the sky and people say, ma belle amie, on the two-level future to team, merci.
Thank you, Aaron, for that nice introduction. Okay, yeah, we're talking about quality, safety, security of compilers. They're not exactly the same, but they are very similar. And to show you they're not the same, yeah, suppose you're compiling a program with your compiler and then the compiler crashes. You would think, okay, that's a very bad compiler, that's a rubbish compiler. But on the other hand, you could also be grateful because it's a very safe compiler when it crashes, because at least it doesn't generate any code that would harm your application and would end up in your user application. But in general, they are very similar. So anything that you do for quality is also good for safety, and anything that you do for safety is also good for security. But you cannot do security alone. You cannot just focus on penetration testing. That was one of the questions. You have to make sure that you're dealing with your quality. You have to deal with everything that you need to do for safety as well. Now, out of these three, I think functional safety, the middle one, is the most well developed. It's very well anchored in all kinds of documents and international standards. It's been applied for a long time, as we'll see in a moment. So I'm going to talk a lot about that, but everything that you do there is also useful for safety. We have to think about what can possibly go wrong with our compiler. Well, Vance already mentioned the compiler is a very central component in application development. So when you're developing a piece of source code, maybe the control for your brakes in the car, that has to be compiled by the compiler, and then it goes into the car. And I'm showing this car over here. That's not an example because this car is full of software, but surprisingly, the manufacturer of that car has not licensed our validation suite yet. And that's really surprising because what can you do with that software if you cannot trust the compiler with which you compile that software? The question is, yeah, do you need to qualify the compiler or do you not need to qualify the compiler? So qualification of a compiler is a process. It is well described in the functional safety standards. It's also well described in the aviation standard, DO 330, but that standard actually makes it very hard to qualify a compiler. There's a very high bar to reach there, because it really requires you to look inside the development of the compiler. Now, compilers are extremely complex pieces of software developed over many, many years. It would be very hard to find a compiler that doesn't have a history of more than 20 years of development. So that's very hard. But you're not doing it to satisfy this document, the DO330 document. You are doing it because you want to know and understand what's wrong, can possibly go wrong with your compiler. Same thing, security standard, the ones that Aaron mentioned, they're relatively young compared to functional standards. So they're still under development, especially when it comes to tools. What do you have to do to make your compiler secure? There's no process for that. But on the other hand, we have very good functional safety standards, 61508, the 26262 standard for the automotive industry. They provide very practical guidance for compiler tool qualification, and especially the 26262 standard is very process oriented. It tells you step by step, and we'll go to the steps in a moment, how you can qualify your compiler. And the final step, compiler qualification, will uncover compiler issues that you want to know about. And I can give you an example of that, a qualitative example. This is the result of a test run with SuperTest, our test suite, for GCC, G++ compiler version 7. The version is not very important. If you take the latest G++ compiler, you will find similar results for C++ 14 compliance. And then what you see is that with standard default settings of the compilers, you find many compile time failures, 81 failures, 93 tests that have been flagged with checked, which means, okay, you have to further inspect that test result because the outcome of that was not quite clear. So about 200 cases here in total where you may want to check whether the compiler is doing the right thing. Now, these are not small numbers. This is an enormous amount of work if you want to mitigate every one of these potential problems. Now, fortunately, if you know about this, you can look about these problems and you can change and tune the tuning of the compiler, make it more compliant. You will not get it down to zero with this open source compiler, and it's very hard to find any compiler out there with which you can turn it back to zero, but at least you can have a very good handle on it. Now, functional safety, as I said, is a very well established domain. This is a picture from about 1850. In those days, locomotives were being developed and sometimes the boilers would explode. The English viewed this with a bit of amusement. They thought, okay, well, that's all in the name of progress. In Germany, people were a bit more worried and they thought, okay, how can we prevent this? And the first instance that you comes up is then, okay, we're going to prescribe how you have to build this boiler. But that is not the way functional safety standards have been developed to work. Now it's about checking the process with which you build the boiler, verifying that that process takes safety into account. Now, when you take functional safety to compilers and compiler qualification, the goal is to develop confidence in the use of the compiler. You want to make sure that the compiler does the right thing. You want to make sure that it does the right thing for your use case. You're using this compiler with specific option settings on a particular machine, host machine, for a specific target. So you need to qualify the compiler for that use case. And you do that by verifying the compiler generates code that behaves according to the language specification. The language specification, by the way, doesn't tell you what the compiler should do, which is create a certain set of assembly instructions. It tells what the executable generated, the assembly instructions generated, have to do when they're executed on the target. So they describe the behavior of the program when it's executed. When you find problems in the compiler qualification, you have also to find mitigation for that. You cannot expect the compiler to be 100% perfect, and it will not be 100% perfect. But where there are errors, you want to define mitigations, work around on how to not fall into those traps. So tool qualification is very well formalized in the ISO 26262 standard for the automotive industry. The functional safety standards are very similar to each other. Maybe the outlier is the DO 330 again, because that is much more strict when it comes to qualification, but other standards for industry applications in general, railway, cars, they are very similar. The goal, the confidence in the use of software tools, that is the chapter with which compilers are qualified. That is part of, section 8 in part 11 of the 26262 standard, and it describes the process of tool qualification for a specific use case. Important too is that the tool user, the one who creates the application, that is the person who is responsible for making sure that the tool is working as is required for their application. It's not the vendor that is responsible for this process. Now, at first, compiler qualification may seem like a very daunting process because compilers are huge. They're literally elephant size. The compiler may have 5 million lines of code. Typical GCC, LLVM compiler, they are so big. So they are huge, but the process of compiler qualification can be broken down into manageable steps. And the steps are described here. First, planning of how you use the compiler, what does it mean, what's compiler you're dealing with, then evaluate how you want to do, or actually if you need to do the qualification at all, then a choice of qualification methods, which actually for compilers is quite easy, then the actual validation itself, and defining mitigation actions. And finally, you have to nicely document everything and possibly prevent it for review to a third party if you want to stamp a certification for your qualification process. The first step, planning of usage, you have to take into account the maximum SIL level, the safety integrity level, measures that already exist to find errors in the compiler. The specification of the compiler is fortunately very well defined. We have ISO standards for the C language, for the C++ standard. These are very well defined documents, very well understood by many engineers in the field. So that is a great help in qualifying a tool. If you take any other tool, there is probably no no specification for it, no ISO specification, and you may have to provide that specification yourself. That problem doesn't exist with compilers, and that also means that based on these language specifications, we can build a very good test suite. We have to identify, of course, the version and the user manual of the compiler, maybe known errors and workarounds for the compiler, and the final step is the use case. We have to define exactly in our qualification step how we intend to use the compiler. Step 2, tool evaluation. It takes into account tool impact. So the tool impact we've already discussed. All your software is going through this single tool, this compiler. So you better make sure that the tool is working well. It can have a potentially huge impact. So that is always in ISO 26262 terms, it's always tool impact level 2. Tool error detection has to do, okay, how sure are you that if there is an error in the compiler, whatever error in the compiler, you're sure that your testing will already find that. And the guidance of the ISO standard, safety standard is, well, take that conservatively. So in general, you would find that you are in tool detection class 2 or 3. You're not always 100% sure that you will find any error in the compiler. That brings you to a decision table in the middle. And well, if any of the tool impact or tool detection is green, then you are actually done. You don't have to continue with the qualification of the tool. You can stop that process. But usually you will go on to the final step, the qualification methods. There are 4 different qualification methods, and which one to choose depends a little bit on the safety integrity level, but actually for compilers, there's not that much of a difference there. So qualification methods, they range from confidence from use but that's hard to achieve with compilers, because compilers, if you take open source compilers, for sure you get 3 updates per year. So these compilers don't get a chance to be used for a very long time, and you will not get the familiarity with them that you need for that argument. Step 2 and 4, or choices 2 and 4, they really look into the development process of the compiler. As I explained, these compilers have been developed over 30, sometimes even 40 years. And well, those tool development processes are not going to be ready for a qualification process. So that leaves validation of the tool. And fortunately, that's a very good method, because we have a good specification, and based on that, we can build very good tests as well. So we validate our compiler by testing. We verify the compliance of the compiler with a functional specification given that specific use case. So we do the testing for the specific options that you're using in the application. And you also look at the compiler diagnostics. So that is the part that is sometimes under-evaluated. The compiler is also required to provide the right diagnostics. And that is a point that is in many compilers not 100% foolproof. There are many required diagnostics that are not found by compilers, certainly with the default settings. And the third step of the validation, it follows actually from the errors that you found in testing, is that you have to define mitigations for the tool malfunctions. So in general, the process that we apply here for the validation is that we take a test suite, for example, SuperTest. That's a functional specification. It verifies the functional specification of the compiler. We're not looking into the compiler at the unit test level. We're also not looking at a very high level of the requirements on the compiler, although we do also in our test suite have tests for optimization testing, which in itself is a non-functional requirement, because it just talks about we want to have the program faster, but unchanged in its behavior. But in general, we focus on this sort of mid-level in the V model. And the final step, that takes, of course, time, but it's not the most difficult step. You have to document the steps that you've taken in this process, in the tool qualification process, write it down. You may have this documentation process result in a compiler safety manual, which actually prescribes to the application developers, well, if you use this compiler in this way, make sure that you avoid this bug, make sure that you avoid that possible problem in the compiler. And that's basically it. That completes your qualification process. It's not rocket science, as I said, especially in the ISO 26262 document. There's a very well laid out process. It takes a bit of understanding and maybe training to understand that, but it is a very doable process. Talking a little bit about the test suites itself. SuperTest, our test suite, is basically a very huge collection of handwritten tests. The test suite is not itself, doesn't have a high complexity. We want to keep the test simple. We have a very simple test driver. We actually have 2 redundant test drivers, so you may actually verify the results of different drivers, that you get the same answer out of that. And we have some reporting tools that analyze the results of the test runs. We also have an enormous collection of generated tests that's useful in particular for the arithmetic tests, which can be implementation dependent, depending on the data model of the target compiler, to which we can adapt as well. So yeah, I'm not going to give the full overview of SuperTest, but let me highlight here this part. We also have in SuperTest not just tests for all of the C and C++ standards, but we also have tests for MISRC, including MISRC 2012 with the security amendment that Aaron just mentioned. We also have tests for NXK, which is the security library in C that is not very well accepted in general in the industry, but it is basically the only library that exists, standardized library that exists, that helps you to avoid errors with copying and comparing buffers and memory, things that you very frequently do in C and also C++. SuperTest also supports targets running on freestanding targets, bare metal targets. So SuperTest can even run on targets with as little as 4K instruction memory, 2K data memory. You might think those are completely outdated processors, but that's not true. These are still used in huge quantities just to do very small control tasks, and some of them are safety critical. Maybe something like controlling the lights of your brake. That could be a little processor that needs to work well because someone behind you wants to see that you're pushing the brake pedal. Okay, I'll show you a few compiler errors from the things that we find in our compiler testing processes, and then I'll hand back to Aaron. So this is an example of a runtime optimization error. We are assigning here into an array at, oops, let's go back. We are assigning into an array at location 0. Then here we actually use an alias, a pointer alias, to assign again to that same array location, and in the third statement we test the value of that array location. And then in this particular compiler, which is actually a proprietary compiler used quite a lot in embedded developments, this incorrectly thinks that the value of S0 at this point is 42 because it didn't correctly do the alias analysis right. Now that's a very potentially a very bad error, and you as a user of this compiler want to know about this. Importance of the use case. Here is a very particular use case. As you may know, Microsoft is pushing a lot in the Linux directory, so they're now supporting to run Linux executables on Windows systems. Now, if you take a Linux compiler and run that on the Windows system, generate code and execute the code, then you may find that this statement here, the assert statement, is false. You take a particular floating point value, you add something small to it, and the result is smaller than what you started with. Now that's very surprising. Floating point is complex, floating point is difficult, but this should not happen. So that is a mismatch between what Linux thinks floating point looks like and what Windows thinks floating point looks like. The compiler is okay, Windows is okay, but the integration between the two, that fails. Another error, this is from the very well regarded Intel compiler for the x86 architecture. That compiler can do factorization of loops like this. So we have a loop that does a lot of manipulation of array data, but in this case we chose our integer counter to start at the very minimum value of the integer domain at -2 billion, I think. And when it is at that minimum value of the domain, this compiler will generate code that at runtime will completely crash and runs into a segmentation fault. Not so nice, something you want to avoid, and that's why you want to know about these kind of errors. This is C++ error. C++ itself is a very complicated language, and that also means that the compilers for C++ are very complicated. This error in particular has to do with inheritance. So we see class B inherits from class A. There's some initialization of class A from class B, and when we then later on here check the initialization values, we'll find out that this is incorrect. Now this was an error in GCC, I think GCC 7. We actually submitted that to the bug list of GCC, of GNU, and it was very quickly fixed within a week, I would think, but then it still takes a long time before such a fix gets into the final released compiler. So in general, if you find an error and submit it to your vendor, it will take very long to get a fix back. Even if it can be fixed quickly, the compiler itself has to go through a renewed validation and testing process, and that will take time. So in general, you would prefer mitigation of errors over asking your vendor to fix things. In general, I've said it a couple of times already, no compiler is perfect. And that means in mission critical application, you want to know what are the weak points. Compiler testing is a very useful test to find out about compiler problems, both for compiler developers, but also for compiler users. And if you really think that elephant is too big for you, then at least check with your compiler supplier what is the kind of test suite that you're using, or with your car manufacturer, are you actually qualifying the compilers that you use to create this car? So compiler qualification has a lot of benefits. It will make you sleep better because you can be more relaxed that your compiler, this big complicated thing, actually does what you need it to do, and that you can work around the problems that it possibly has. It allows you to decouple application development from the compiler testing. That's part of the upfront planning that Vance already mentioned. You can decouple these processes, and that reduces time to market. It also provides flexibility. If you do the compiler validation in-house, once you have set it up, it makes it easy to change small things. You may want to change the use case, the configuration, but once it is set up and you have your testing in-house setup, compiler validation setup, then changing some small things is not complicated anymore. And basically you push the button, and your standard continuous integration process will take care of validating a new version or a new configuration. So again, compiler qualification, it is not rocket science. It can be broken down into manageable steps. And with that, I want to pass back to Vance, and he's going to tell us some answers to questions, I think. Let me see, where are you, Vance? Change presenter.
Fantastic, Marcel, that was wonderful. We have a big thank you for Marcel, Functional and Solid Sands in the Netherlands. Really super product. So folks, now you've had an introduction to compiler validation, cybersecurity, safety critical software. How did you do on that quiz? 7 questions. Remember, a long time ago, exactly 43 minutes. 7 questions. Let's see how you did. I saw some of you submitted your answers online. That was clever. I replied to a number of you. Here's the answers. Folks, they're all false. Let's consider. Number 1, software testing is the best method to improve quality. Software testing, just like testing your old car over and over, doesn't make it a new Lamborghini Mercedes. It just shows how big a gap there is between my and your old car and that Lamborghini Mercedes, okay? Testing assesses quality, does not directly improve it. Improvement comes from the processes, the feedback, good compiler, cybersecurity awareness, safety critical awareness. It's false. Number 2, buying a great Lamborghini Mercedes means you can always trust it, right? No, exactly. Same with compilers. Yeah, that's what this is all about. Number 3, cybersecurity should focus primarily upon penetration testing. Yeah, penetration testing is important. It's a fundamental aspect of cybersecurity, okay? However, it is not the key. So, number 4, also false. Compiler libraries are typically well tested. They're use case tested. They're exercised, not necessarily tested, and definitely not with sufficient security and reliability. So it's incumbent upon you to use compiler libraries. Does that mean you should simply discard, throw away your compiler libraries, start over from scratch? No, as a certification authority, we would say your probability, if starting from scratch, of introducing an all-new error is greater than using a proven library. However, no library is guaranteed perfect until you verify it. So compiler libraries need to be better tested, especially for cybersecurity. They're really important threat vectors, places you can penetrate and cause problems. Number 5, dynamic software testing. Remember, dynamic, static, dynamic, executing the software, likely on a target, as if the software were actually executing in your car, medical device, nuclear power, aircraft, is similarly efficient as static testing. Oh, no, no, no. Static testing is computationally expensive, billions of operations, but they happen very quickly. So it's a high ROI, return on investment. So dynamic software testing is important, but the ROI, efficiency, return on investment is better with static testing up front, especially with good compiler, especially with DO326A cybersecurity awareness. Number 6, compiler qualification is not needed if you do on-target application testing. Ooh, is it possible? Let's be really honest. In any meaningfully complex project, not your cappuccino machine. I'm pointing to mine. I'm working from home this morning. Well, compiler qualification is the only way to assess how good your compiler is. If you had perfectly complete testing of all possible dynamic permutations, fantastic, you don't need it. The odds of you doing that are 0, 0, 0. Number 7, open source compilers cannot be qualified for functional safety. Well, we just had Mr. Marcel Beemster from Netherlands Solid Sands explain why they can be qualified, especially for functional safety. Okay, so now I'd like to turn it over to the Q&A session. We've got a few minutes, as we promised, for Q&A, and there's questions. So we're going to dive into the questions. By the way, if you want more information, you can download the cybersecurity white paper from the AFuzion site here, or download the Solid Sands white paper, which discusses the benefits of compiler qualification here. If you have additional questions, we don't get to your questions, send us an email at info@afuzion.com or info@solidsands.com. With that,